Welcome back, everyone. In this lecture, we're going to be creating variables, placeholders, and graph classes for our manual neural network. So let's go ahead and discuss these, and then we'll hop over to the Jupyter Notebook. A placeholder is essentially going to be an empty node that needs a value to be provided to compute the output. And its purpose is essentially to be a placeholder for data that you're going to bring in. That is the features or labels, etc. So it's just a placeholder that's eventually going to be filled in by the data you provide it. It's a placeholder because you're not going to initially have that data. It's going to come from your data source. Variables are basically already going to be filled in with changeable parameters of the graph. So you can think of that as something like the weights of the actual neural network. Then finally, we have the graph itself, and the graph, the way we're constructing it here, is going to be a global variable connecting variables and placeholders to specific operations. Let's go ahead and jump to the notebook and code this all out. All right, back at the notebook, first thing we're going to do is create the placeholder graph. So we'll say class placeholder. And remember, this is a node that's going to need to be provided a value later on. So we're going to say def init self, and we're just going to initialize it with the output nodes, make that an empty list, and then we're going to grab that global variable for the default graph. So say default underscore graph, and then we're going to grab the placeholders of the graph. So basically, this graph object is going to have a bunch of placeholders, and then we're going to append this placeholder to it when we actually create that graph. And we're going to do something really similar to our variable class that we're going to create. So we'll have variables, and this variable is a changeable parameter inside of the graph. So we'll say init here. It's going to take self, and then usually, often they'll have some sort of initial value, such as randomly initializing the weights of a graph or of a network. And then we're going to say self.value is equal to the initial value. And then we're also going to say, what are the output nodes here? Start it off as an empty list. And then just as we did last time, we're going to append this. So our default graph object is going to have some variables to it, and we're going to append those variables. Okay, so we've discussed this default graph. It's a global object. Let's go ahead and now create the class for it. So we'll say class graph, and we're going to initialize it with 3 attributes. And that's going to be a list of operations in this graph, a list of placeholders in this graph, and a list of variables in this graph. So what is this graph actually doing? This is essentially the main thing that's going to be connecting these placeholders and variables to the operations that they belong to. So again, every time up here in these other placeholder and variable graphs, when we're doing this specific attribute or assignment right here, this, hey, default graph variables append, all we're saying is, hey, this graph is going to contain a list of all the variables inside the graph. So when we create a variable, go ahead and append it to the default graph's variables. And then we're going to have one more method here called set as default. So to make sure that if we have multiple instances of graphs, if we're connected to the right one, we're going to have this method here set as default, and it's basically going to call global default graph, essentially setting this default graph as a global variable, and that's what's going to allow us to access it inside this placeholder, inside this variable class, and also if we come back up here, inside our initial operation. So let's go ahead and add that into our operation class now that we kind of know that it exists. So we'll say default graph operations append self. Okay, so now we have operations, placeholders, and variables, and we have a graph that keeps track of them all in the form of a list, and it also can then set its own graph as a global variable to be kind of accessed by those 3 main objects. And then we'll say default graph is equal to self. Okay, so hopefully now you kind of get the sense that we have this graph object. It contains placeholders and variables. Variables are things that kind of can be changeable parameters within the graph. Placeholders are essentially empty nodes waiting for you to provide them data information. And then operations, well, we know what those are. Those are just computational operations like matrix multiplication, multiply, addition, etc. All right, so now that we have this graph, let's go ahead and work through a really simple example. So we're going to do something really simple. We're going to see if we can, let me make this into a text box. Okay, so we're going to do something really simple. We're going to say something like z is equal to ax plus b. And we're also going to say a is equal to 10 and b is equal to 1. So that basically means we have the following problem. We say, okay, if z is equal to ax plus b, if a is equal to 10 and b is equal to 1, then I should have the following function. I should say 10x plus 1. So now I have a formula here. So I know, let me make this into separate lines here. I know z is equal to ax plus b. If I have these two variables, a is equal to 10 and b is equal to 1, then I have this resulting output of z depending on what my value of x. So x here is a placeholder. Depending on what value you provide for x, we can do these two computations, a multiplication and an addition, to get this actual result. So let's do this with what we just did right now. We'll say g is equal to a graph. So now we have a graph object. We're going to set g as a default graph. Now that initializes this global variable that's floating around. And then we have two variables. That is, we have a, and that's a variable with a value of 10. And then we have b, and that's a variable with a value of 1. And this number 10 and 1 just totally arbitrarily chosen. Okay, then x, we technically don't know what it is yet. That's up to the user to provide, because this is essentially the formula of a line, right? Y equals mx plus b. So we have x here. I'm going to have that be a placeholder. No need to provide anything because it expects it to be provided later. Now I have two operations. I have a multiplication operation here, 10 times x, and then I have an addition operation, the result of that, plus 1. So let's go ahead and do the following. We'll say y is equal to multiply, and I multiply the variable a by the placeholder x. And then finally, my final result is z, where I add in the result of that multiply function, which is y, or multiply class really, and then b here. And then I have z right here. So the only thing left is to actually compute this z. Now in order to compute these various operations, as well as set these variables and placeholders, we need to add in two more things. We need to create a traverse post order function, and that's basically going to allow us to do a post order traversal of nodes, and that essentially makes sure that the computations are done in the correct order. For instance, I need to make sure that I multiply this out first before I add these two. Right now, nothing's actually being done here because we haven't run this. Once I have that traverse post order operation function ready, then I can create a session class, and the session class is going to be the thing that actually executes this graph. So right now I kind of have all these empty things. None of these things have actually happened yet. I haven't actually multiplied anything. I haven't added anything yet because we're essentially still waiting on that placeholder. So in the next lecture, we're going to add in a function called traverse post order, which is going to do a post order traversal of nodes. Post order you may be familiar with if you've ever done anything regarding tree theory with computer science. And then we're going to have a session class, and that session class is going to be the thing that actually executes everything. Okay, so let's go ahead and do that in the next lecture.